Hi, grade sevens. We touched on this during class time, and I want to make sure that we're clear as to where we're going here. Where in the past we've talked, I guess you can almost talk about the theory, like the patterns that you can find in ratios. This year, we're going to take a look at how to apply those ratios. How do you take the information in a ratio and actually use it? Okay. So in order to do that, I want you to think about a couple of different things. First of all, I want you to think about scale, which is something that I saw some of you struggling with when we were building some things last year. And I want you to start thinking about number patterns. I know that's what the grade sixes are doing, but the patterns are going to get a little more complicated, all right? And in order to do that, let me give you a couple of examples of how specifically to apply this type of ratio. Here we go. Okay, let's work out a couple of examples here to see if we can at least get an idea of what we're supposed to be doing. Okay, let's talk about a girl. Let's make up a name, Jill. Jill wants to build a house, and she's got a scale drawing of her house. And the scale drawing that she has to her house is 5 centimeters is the same thing as 1.5 meters. Now, this is a type of ratio. 5 centimeters to 1.5 meters is a type of ratio, but it's not a proper ratio. The problem with it is that, well, for one, like an improper fraction, we can change those numbers around so that they're a little more clear. But also, there's a big difference between centimeters and meters. And although they're related, they don't really work very well when you're looking at numbers of this size, especially if you're trying to figure out something in the shape of a house, for instance, a big piece of area. So let's see if we can get this down closer to what would be a ratio. Okay? So a ratio, if we left it this way, would be 5 centimeters, 5 cm, then with a colon, 1.5 meters. Okay. Now again, this still isn't a proper ratio, but at least it's put it into a way that we can see it as being one. In fact, instead of saying 1.5 meters, to make it easier, we should put them both on the same measurement, right? We should put them both into the same numbers. So 1.5 meters is like saying 150 centimeters. So the ratio is now 5 to 150. But there's a problem. Again, that number isn't proper. I mean, it's just too big, and it's an improper fraction. So if I divided both sides by 5, I would get the proper ratio, which is 1 to 30. So this scale of 5 centimeters to 1.5 meters is actually the same as 1 to 30 as a ratio, which means I can start looking at things a little bit differently when I start looking at her drawing. For instance, let me just get a shape here. Her house is, let's use a rectangle here, okay? This is her bedroom. And in her drawing, I'm just going to get a line here so I can show you what I'm talking about. In her drawing, from here to here, right across here, in her drawing, that is let me see now, 16 centimeters, okay? It is 16 centimeters from that end to the other end in terms of her drawing, okay? Kind of big if you think about it. It's going to be a large bedroom on that line, but think about this. If that's 16 centimeters, then how do I figure out how long that's going to be once I start building the thing? Because remember, it's in a ratio. Well, the way I could do it is measure this here on the drawing and use the ratio to figure it out. So now, instead of using, instead of trying to sit there and try to figure out everything from the very beginning, I've got 16 centimeters. And if the ratio is 1 to 30, then it's really 16 by 30, isn't it? Which is equivalent to 480 centimeters. And since 480 centimeters would be tough to do, how many meters would it be? Well, there's 100 centimeters for every meter, so that would mean that we're actually looking at a space that's 4.8 meters. Okay, so we've used a ratio to figure this out. What if we were looking at the side of her house? Okay, instead of looking at the side of her bedroom, now we're looking at the side of the house, and instead of 16 meters across here, or 16 centimeters across here on the drawing, it's now 18. How would you be able to figure out how many meters there are here? In fact, you know what? Let's change it a little bit. We want to draw a diagram. Instead of going from the diagram to reality, let's go from reality to the diagram. Her house is 18 meters across here. How long would that drawing be if it were on the blueprint? Using the very same idea here. Try to figure it out. I'll give you a couple of seconds. You got it? Okay. What you would have to do now is change 18 meters into 1,800 centimeters. With me so far? Okay. And then you'd have to divide that by 30. Because that way, you'd have it down to the scale. 1,800 divided by 30 equals 60 centimeters. Okay? So the drawing would have to be that wide in order to make it work. Okay, so you got it. What I want you to do now is practice that on some of the questions that I've given you. They're located in the book. Go through them, or on the website. Go through them one at a time and see what you can come up with. And then we'll go through it a little more deeply tomorrow and see how you do. Good luck.